Hi, here we have another question from Iran Mathematical Olympiad, round number 1, year 1997. This, together with another question, was probably the most interesting questions in that competition. Okay, so question says we have 25 points and these points are on a circle. Find the minimum number of arcs that are equal or less than 120 degrees constructed by these 25 points. So first round of Iranian Mathematical Olympiad is usually consists of multiple choice questions. You get 30 questions for 3 hours, so 6 minutes per question. Because this question was a little bit difficult, at least to my taste, maybe you can spend 10 minutes or 15 minutes try to solve the exercise and then come back and see the solution. All right, let's see how we can solve this exercise. All right, so we can start with some simple examples when we see such an exercise. I put all these points, 25 points, at one location close to each other. Obviously, in that case, every 2 points will create an arc that is less than 120 degrees. In that case, the total number of arcs will be 25, choose 2, and if you do the calculation, it becomes 300. So the maximum number of arcs that we can make that has equal or less than 120 degrees arc, there will be 300 arcs. But obviously, we want the minimum number of arcs, so we have to find examples that are lesser than this. Another case, maybe we can say that we're going to uniformly distribute all these 25 points on the circle. If we do this, obviously the arc between each two consecutive points will be 360 degrees divided by 25 will be 14.4 degrees. And because each of them should make arc less than 120 degrees, that means if I divide 120 to 14.4, this gives us 8.33. So it means if I take 1 point here, there would be 8 additional points on the right side and 8 additional points on the left side that creates an arc equal or less than 120 degrees. Basically, for each point, we will have 16 arcs. Okay, so then the total number of arcs will be 25 times 16. But because every time that we calculate an arc, actually we are counting it 2 times. Therefore, we have to divide it by 2. It becomes 200. So if we uniformly distribute this point on the circle, we will have 200 arcs that are equal or less than 120. But maybe we can improve even further. So obviously, in this case, I decided to put some of the points in one location and the rest in the other location opposite to those initial points. So in this case, for example, 12 points here and 13 points here. So totally will be 25 points. And then if we calculate each of these 13 points that are located in one corner, that will be basically creating arcs equal or less than 120 degrees. And each of these 2 points, they will create arcs equal or less than 120 degrees. Then total number of arcs in that case will be 13 choose 2 plus 12 choose 2. And then if you do the simplification and calculate, this becomes 144. Obviously, we don't know what the correct answer is. So far, we know that this one is the minimum among the 3 examples that we have provided. Now I'm going to give you the final solution. I'm going to prove that this example that we give actually is the best possible and is the minimum number of arcs. Okay, let's assume one of these points and consider that this point has the minimum number of arcs that are equal or less than 120 degrees. So this is a special point. It's basically having the minimum number of arcs. For this point, we say that the number of arcs is equal to k. So this k is the minimum number of arcs that each point can create. Obviously, from looking from this point, since there are k other points surrounding it so that it creates k arcs, the remaining points are all within this region. And that means all of these remaining points, at least they create, if this is 1 point and these are k, so there will be totally k plus 1. So the remaining points will be 25 minus k minus 1. Choose 2. This number of arcs we have at least between these points that are here, because all of them will be equal or less than 120 degrees. Okay, so that is basically this. So the total number of arcs that we can have is for sure larger than the number of arcs that we have in this place, plus the number of arcs that we have for these other points. So how can we calculate them? Totally, we have k points here, and this point together will be k plus 1 point. And because this is the minimum number of arcs, which is equal to k, that means all these other points, all the other k points, they have at least k number of arcs. So basically, for all of these k plus 1 point, we will have at least k times k plus 1 arcs. And because every time that we calculate an arc, we are actually calculating it 2 times, because to look from this point, we calculate 1 time, and then from the other point, it's actually the same arc. So we have to divide by 2. So what we can say is that the number of arcs are equal or larger than this number that we have here. And now we can simplify this number. Obviously, this one becomes 24 minus k, choose 2. And then you simplify, it becomes 24 minus k times 23 minus k divided by 2 plus k times k plus 1 divided by 2. And then, yes, you multiply and add them together. You get to this. You simplify 2. You get to this number. So the total number of arcs that we have will be equal or larger than this number. So in order to find the minimum of this second order polynomial, we are going to take the derivative. The derivative will be 2k minus 23, and we equate it to 0. And that means k has to be 23 divided by 2. But because k has to be an integer, that means k is either 11 or 12. We can do the calculation. If k is equal to 12, this value becomes 144. And if k is equal to 11, this value becomes 144. So remember that when we say k is 11, together with 1 point, it becomes 12. So it means we have 12 of them here, and the 13 will be here. If k is 12, together with this point becomes 13. So 13 here, 12 here. And basically, we should have them so that they are close together, and these other parts are also close together so that they don't create additional arcs. Otherwise, the number will be more than 144 arcs. Therefore, the correct answer would be option D, 144 arcs. Let's see what we have learned. So consider the obvious cases and try to evaluate the solution corresponding to those cases. In many situations, when you evaluate the obvious cases, basically you probably are going to find the actual solution. And then you need to prove that the best solution you found is really the answer. So consider a point or an element in a set that has the minimum or maximum number of a given property. And by considering that point, you can basically try to drive additional information, and from there you can solve the exercise. All right, so that's end of this video. I hope that you learned something new. See you next time. Bye.